So I'm going to do 2 brief presentations and then a little bit of homework, and then we're going to break for lunch. I'm going to talk about a kind of session called an intensive session. And an intensive session is designed specifically to measure EOP. It's a short 1-hour session, so it's about the simplest kind of session you can have. This afternoon, we're going to be scheduling a session with Fortaleza, Verão, and Verão, which is also a 1-hour session. And it takes about 2 weeks for this data to be processed. The other is short 1-hour sessions called intensives. And these take about, turnaround time is about under 24 hours. It's a few hours. So here is a chart showing the kinds of EOP sessions we've run over the years, over the last 40 years. And one of the things that's happened is that the network we use has gotten larger and larger. A long east-west baseline, and the reason you need a long east-west baseline is I need a pen. The reason you want a long east-west baseline is you want to measure rotation about the z-axis, so like this. And if I have a, VLBI measures the difference in delay. If I have a point here and I rotate about this distance, then the time the signal takes to get here and to get here is going to vary. On the other hand, if I rotate about the other axis, nothing is going to happen. So that's why I want the long east-west baseline. And here's a chart showing the 2 antennas involved in this. One is Koke, and one is Verão. And these have both been observing since 1993. Verão since 1983, Koke since 1993. So when you're doing a VLBI observation, whatever you're looking at has to be visible at both sites. So that places a severe limitation on what you can do, because a quasar or a source can be visible at one site but not visible at another site. So here is a chart showing a typical intensive measurement at Coquet-Vetzel, and you see that crescent at the top. That crescent at the top is the only part of the sky that is visible at both Coquet and at Vetzel. So that's a relatively narrow slice of the sky. The interpretation of this is that the center of the plot is when Coquet is straight up. The top of the plot is when Coquet is pointing at the horizon in the north direction, and the two edges are when it's pointing in the other directions. So do you guys understand what this plot shows? So one of the things that you're doing, so if I look at this, there are 23 scans. So I have 20 this hour. And generally speaking, the more observations you have, the better. The more measurements you have, the better. So this afternoon, when you're writing schedules, you're going to change some parameters to try to increase the number of observations. Now, one of the questions you always have is, how good are your observations? And earlier today we talked about least squares, and least squares gives you one estimate, but really what you like to do is compare things together to see how much they differ. And what I did is that I compared the results from the intensives with the results from 24-hour sessions. And here's a plot showing the two 24-hour sessions I have every week, and then the 5 intensives I have. And you can see that 4 of the intensives are very close to the 20. So I can use that as a comparison to compare the UT1 estimate from the intensives with the UT1 estimate from the 24-hour session to see how well they agree. One of them is displaced. There's one which is a long ways away. It's a day and a half from the 24-hour session. And that one, the error interpolation would lead to a 60 microsecond error. So that's not good for the analysis. So if I compare the intensives with the 24-hour sessions, here's a plot where I show the difference in microseconds. And I find that the RMS is about 22 microseconds. So that gives me a measure of how good my measurements are intensives. Now the site Coquet-Vetzel is interesting in that at both Coquet and at Vetzel, they have a legacy system, an SX system. They have the next generation system. The next generation system is small, fast-moving antennas. So here's a chart that shows the, well, let me just talk about this. So one of the problems that you have with the intensives is that they only look at a small slice of the sky. And so this limits how many sources you can see. So, you know, we had a list of sources that we used for the intensives, and if the list is too limited, then your geodetic results are bad. Another problem is that each source is observed many times. And if there's something wrong with the source, then you may not have any observations on the source. What can cause this? Well, one of the things that when you schedule your observations you put in is the strength of the source, how strong the source is. And the strength of the source changes with time. So if you have a wrong model for the strength of the source, it could be, and the source is weaker than you think, then you may not detect it. So, and so we monitor how strong the sources are and update the catalog with that all the time. Another issue is that you only have a small number of observations, typically 15 to 20. So this means that your estimates are not as good as they otherwise would be. And it also means that you're limited in what you can estimate. So there are lots of things that you have to assume, which otherwise you would estimate. Problems in your models, in your a priori, this can lead to errors in your estimates of UT1. So here is what the newer antennas at Koke and Betzel look like. And Fortaleza is getting one of these antennas. It's going to look pretty much, I think, like Koke does. And these antennas are small, but they move fast, and they are broadband. And here is a chart on close to the same day showing an intensive session using the SX antenna and the Vigos antenna. Now, I'm not sure if it's obvious or not, but on the Vigos antenna, the one with the 68 scans, there is sort of a hole in the top corner. And the reason there's this hole is because you have the 20-meter antenna, the old antenna, you can't see through that. So that's in the way. So you can see that this has, the Vigos antenna has more observations.
Okay, thanks.
Okay, so going back again, this compares intensives done with these two different pairs of networks. One is a legacy SX and one is a Vigos. You can see the Vigos gets almost 3 times as many scans. And I can do the same sort of thing. I can compare it against the 24-hour sessions. And here's a chart showing the comparison with the 24-hour sessions. And the agreement is better. Previously, I got 23 microseconds, I think. Now I'm getting like 16 microseconds. So that shows that the new intensives help. So that's it. So the point of this is I wanted you to understand about mutual visibility. That puts limits on your observations. And this afternoon, what we're going to do is we're going to start off with a SX schedule, and then we're going to change some parameters in the schedule to try to increase the number of observations. The parameters we're going to change are the sensitivity of the antennas and how fast the antennas move, because each of those will influence things, and you can get a feeling for what the different sorts of effects are. Okay. So I have one other short presentation, and then some homework, and then break for lunch. So how do I choose another presentation?
One second. What presentation you want to show?
Let me see. That one.
That?
Yep.
Okay. Presentation. Loading. Let's close another. The last. Okay, close that.
Yep.
Close that. No, it's the wrong.
That's the one.
Okay.
That's it. Yep.
Okay. Google. Google. Okay. Presence. Share screen. Okay.
Okay. I'm going to just do the start of this presentation because I want to give you an introduction to how the VLBI data is organized. And then when I'm done with this, the homework is going to be, you'll use this information to look at some VLBI data and get some information. So the way that an individual session is organized is the data is put into something called VGOS-DB format. And the VGOS-DB format is you break the data up into small files, small pieces, each of which has either similar kinds of data or applies to similar parts of the session. For example, Fortaleza has data, has metadata. And so, the metadata, first off, metadata, this means meteorological. It's weather information. So the metadata at Fortaleza is in one file. I have the metadata at VetCell is in another file. I have no reason to put them together because they're separate. And if I later discover that I have a problem with the metadata at Fortaleza, I can just change a different file. So I have lots and lots of files, and these are organized by something called a wrapper. So the wrapper is a list of the files that correspond to a given session. Within the files, and the wrapper is an ASCII file. The other files are netcdf. And netcdf is a data format that's used in many areas, and it's open source. There are many languages that use it. It's written in binary format, so data access is quick. And since it's in a open source format, that means anybody has access to it. They don't need to have special software, they can just use it. So here is a schematic showing how the data is organized in a session. I have a wrapper file, and then I have, the wrapper file has pointers to lots of other things. The wrapper file has an extension WRP, stands for wrapper. Now, suppose that I have, Goddard has analyzed a session, and somebody else has analyzed a session, and I want to compare values. Well, I can just change my file to this other institution, and then I can see what the results is of using their stuff. And here is what a wrapper looks like. You can see that it's ASCII, you can read through it. Any place it has something like head.nc. The NC means that it's a netcdf file. So let's see, it goes down there. At the top of it, it has a brief history about the wrapper. If I go down to where it says begin station Kokei, it has information about Kokei, everything that's there. It tells you where the directory is, Kokei. I have the same sort of thing for other stations, and then I have observations. These netcdf files have a naming convention in that there will be some name with a dash or an underscore. And the name, the first part of the name tells you what's in the data. And then after that, you can give extra information about it. So here is just a more complete description about this. You can have, if you have similar kinds of data, but they differ slightly. You can say what kind it is, like you can also give a version indicator, or you can give an institution indicator. So here is some examples of a NetCDF data file names. So if you understand what it is, it should be fairly self-evident, like time UTC. What does time UTC contain? Somebody say something. It contains the time. And a NetCDF, abstractly, a NetCDF container file can be used as a container for arrays. So you have some NetCDF file, and then you can have an arbitrary number of arrays in there, and then you can reference the arrays. Okay, I think that's enough for right now. Now I want to let's do the homework. And can I change slides? Sorry.
Excuse me, teacher. Next slide is
this one here.
saving.
Yep,
Is that?
that's it.
Okay. Let's go to Chrome. Presence. Share screen. Okay, is that it?
Yeah. Okay. So here's the coursework: is log on to your computers and navigate to that directory there. Got it? So that's a 22 January 03 XU is an intensive session. So you can see all of the sessions are organized in directories. So this is the directory for this session. So try typing that ncdump head.nc and see what you get.
Is in this page?
I can't see that far. My eyes.
Open terminal.
Is here?
Yeah. Uh-huh.
Okay.
Yeah.
Thanks.
Is that teacher?
Yep. Uh-huh. Uh-huh. Yes, that's it.
Okay.
So the file head.nc has summary information about this session. It will tell you what sources were in the session, what stations were in the session, what the start and stop time were of the session.
Okay.
And the utility ncdump will just take a netc file and convert it into ASCII. So it's a reasonable way of seeing what is in a file. Let me, can I see what you have? Sounds too long for me.
The duration is 54 hours and 59 minutes.
Should be, it's like 1 hour, or it's like, should be 59 minutes. It's just 59 minutes.
Oh, okay, 59 minutes.
Yeah.
Oh, okay. They,
So if you're done looking at head.nc, go to, there's a subdirectory there called cok. Go to cok and do an ncdump of met.nc. And that will tell you what the met data is like there.
Station 2, teacher.
Pardon?
Station 2.
Yeah, so what stations are in that session?
Number station 2.
Yeah, and what are the names of the stations?
Ah, okay. Let's see. Ah, okay. Ishoka Wetzel.
Okay. Okay.
Vai na pasta raiz. Você já tá na pasta raiz. Vai lá no HD. Cara, não sei usar Windows. Cara, isso é a mesma coisa do Windows. Você vai aqui, ó. Computer. Outra location, ó. Computer.
Other locations.
Ó, SGP, ó, SGP, VLBI, Level 2, VGOS, 22, agora Ctrl F, aí você coloca 22, January, 03, Exclude. Aí tu acha que a pasta, aí você clica com o botão direito, Open Terminal.
So let me ask, has everybody been able to do this exercise so far?
No. We are not finding the information.
Who's not?
They are not have experience using Linux.
Ah. If you want to bring your computer up here, I'll be happy to help you.
Ah, do the same on, okay, let's the next lesson. Back.
I am here and I don't know what to look for here.
Okay, go up a level. So, head.nc. That we want to do a. How do I open a terminal window?
Here, I think.
Não, não vai baixar. Ele vai descompilar esse arquivo. Ele vai compilar esse arquivo. Ele vai compilar. Mas já tá bloqueado. Compilar. Ele vai pegar o dado e vai estruturar. Ok, agora.
Okay, so this is the same information you had before, but just in a terminal window. So now if I do nc dump head.nc, this will tell me what is in there, and so one of the things it tells me is those are the stations that are in that session, and that is how long they observed for. So did you follow what I did?
Yeah, yeah.
Okay.
I don't think I will remember, but
So I mean, the way you do in Linux is you use the CD command like that,
Okay.
and then you just type in wherever you want to change to. Okay.
Okay. Thanks.
23 hours and 59 minutes and 59 seconds.
Sounds good. Sounds about right. Okay, guys, this is all I have for right now. And this afternoon, I'll give a presentation on scheduling